Welcome to Splunk Talk. A Splunk podcast that's all Splunk and no junk. I am your host, Birch. Over there, we've got...
Hey, morning. It's Hal.
And we've got two special guests today, Sirish and Patrick. But before we get into any of that, good morning, second day of conf.
Yep, we're still going. We're still alive. I don't believe there were any fatalities. Did you hear about any fatalities yesterday?
No.
I think we're in the clear. So perfect safety record.
But I've been in this channel with you the whole time. So what do I know?
We did. I think it was 5 yesterday. So that's a new
5.
world record. 5 live streams of the SplunkTalk podcast in 2020 at conf. That's a new world record.
And I, even though it's a virtual conf, I do feel like I physically, my body is exhausted. So that's how I know it's a real
feels
conf.
exactly like a real conf.
Yeah. And just an update. So now I have one bingo because I know people are following along at home. And now I'm just looking to rub it in by getting some other spots as well. Cool.
I like it. Let's this is a special episode. I want everybody to pay attention. We're talking about Kubernetes today, okay? And kind of where Splunk is going with it. We're going to talk first about our guests. So why don't you start us off, Patrick? Tell us a little bit about yourself.
Yeah, sure. My name's Patrick Ogdin. I'm a product manager for Splunk. I've been with Splunk actually 12 years this month. Been in sales engineering. I have been doing product management for a while now. I've worked on monitoring console, search head clustering, a bunch of things that made their way into the core platform. So very excited to still be here.
What's the oldest feature that you can think of that you shepherded?
Oh, I think one of the first things I worked on was forwarder management UI. And then also we worked on some stuff that had to do with structured data inputs. So the header stripping in like IIS logs and CSV handling. That was one of the first things I ended up working on. Yeah.
Thank you for that. I appreciate it.
And here's a little factoid. At my very first conf, when I was a wee lad in 2013, Patrick doesn't remember this, but I attended, I think he did a talk on the monitoring console, back then called the DMC, the Distributed Management Console.
That's right. Octavio and I.
Yeah. And fell in love with him then. And then I've been secretly in love with him. And then only recently realized that I remembered meeting him and talking with him a lot after that talk. He doesn't remember it at all. So it's a very one-sided relationship.
So Patrick is not the only guest today. So let's be sure to introduce Sirish. Morning. How's it going?
Yeah, good, thanks.
How long have you been at Splunk?
I've been with Splunk for close to 6 years now.
Oh, wow. I fall down on the job here. I've not here as long as Patrick, but we've been, Birch and myself, 8-ish years, and you can't know everybody anymore. And there was a time at which you could realistically know everyone. That time is long past. So tell us a little bit about yourself.
Sure.
What's your Splunk journey?
Yeah, as I said, I've been with Splunk for about 6 years, but most of my time has actually been down under. I joined Splunk in Sydney, Australia. Started off with support, moving on to engineering, and then moving on to engineering management before being transferred to the headquarters here in San Francisco last year. So I'm currently managing a team of software engineers here in the Bay Area too.
Awesome. Is that really like shepherding cats, herding cats? That's kind of what I heard the job is like.
No. Yeah, I really enjoy working with my team. Yeah.
So let's first maybe, Patrick, what is the news? What are we talking about today? And we'll kind of get into the details for the next 20 plus minutes.
Yeah, sure. We announced, I guess dropped yesterday, the latest release for the Splunk operator for Kubernetes. So this is a journey we've been on for, well, actually a couple of years now. But the big news this week is that we've officially moved into beta for the Splunk operator for Kubernetes. and we added a bunch of actually Sirish's team added a bunch of very cool features into the beta as we head towards making running Splunk in a distributed fashion on Kubernetes, containerized, fully supported, and good to go.
Okay, so let's back up a little bit and talk about why would someone, I guess, why are people running things in containers and Kubernetes in particular?
Yeah, it really is. We're getting closer to this more cloud-like deployments for customers that are running things either on-prem or really where we're seeing a lot of this is also in the cloud, public cloud providers. So places like Amazon and Amazon's Elastic Kubernetes service and GKE and Azure. So this gives us a way to sort of take the traditional Splunk, the enterprise product that we built, not necessarily to be containerized over the last 20 years, and put some wrappers around it such that it looks more like a containerized, scalable service when running it in a cloud-like infrastructure, on a cloud infrastructure.
So is this the same journey as what Splunk has been doing with Splunk Cloud, the service?
To a degree, I think there's there's a method. There are ways in which we're currently running the Splunk Cloud, and then there are the new ways that we're looking at Splunk Cloud, and we're evolving both of those at the same time. And both of those definitely involve container-based services to deliver the Splunk Cloud service.
Okay.
So what's the sort of like compelling reason for this? Like I'll be a haggard here, and I'll
like
I
Merle
like
Haggard,
my
or?
yeah, sure. I like my traditional, install Splunk on my server. I got it running there. Seems to work fine. What's with all these hippie kids and their containers? What is that? What is the value of doing any of that for Splunk software specifically?
Yeah, so I think in this case, really, we would like to say that we're taking the toil out of sort of the setup and administration. I mean, really, where this comes into play is when you're running Splunk distributed and also at scale, because in any of those environments, we have to, we have to either have the customer build things in, say, Puppet Chef or Ansible to build automation around things like the coming and going of, say, VMs or bare metal servers, or just getting all of the bits out into a distributed environment when you're running Splunk, when it's not containerized and not running under Kubernetes. So the Kubernetes backplane gives us a lot of, I guess, flexibility to integrate third-party products. The project that we're currently working on heavily leverages the Docker Splunk GitHub project, and also, importantly, the Splunk Ansible project, which is where we get a lot of this good automation. And I can just build a search head cluster or build an indexer cluster and have all the pods in the in Kubernetes just sort of automatically come up with the service ready to go. Whereas all of this would be either something the customer would have to hand code and build themselves, and we've sort of taken all of that out of the mix.
Okay, so you just threw a few technologies at us, and what I want to know is, if I'm a Splunk admin, tell me, what more do I need to learn and understand in order to administer these things effectively? And I see you nodding, Sirish. You want to kind of take that?
Yeah, go ahead, Sirish.
Sure. I think as a Splunk admin, the Splunk operator has tried its best, and we continue to work on the product so that we make it as easy and as seamless for Splunk admins to be able to install Splunk in a Kubernetes environment. Having said that, some degree of Kubernetes knowledge, what are some fundamentals, right? What are the pods? How to set up the Kubernetes? How do you set up the networking within Kubernetes? How do you open it up to the outside world so that we can start ingesting the data from forwarders and so on? So these are some fundamental concepts that would be nice to have as a Splunk admin while you're using the operator to install Splunk within Kubernetes.
So what would a workflow, I don't know, there might be a typical versus an ideal workflow with deploying Splunk in this sort of environment for somebody that is new to containers in Kubernetes? Would you foresee them passing it off to a development team, or do they really need to be closer to that process?
Oh, the workflow is actually, we have made it as simple as possible. All that an admin has to do is to just call a couple of commands that we have documented in our documentation guide using the kubectl APIs. That would set up the operator, and then use certain YAML files to install whatever configuration that we want. Say, for example, an indexer cluster or a searcher cluster or whatever. So it's as simple as possible. So I don't see why an admin would need a development team to be involved here.
Okay. So it kind of sounds almost like, but almost like just another operating system that you can run Splunk on. So I go to Splunk.com, download, and I can download it for like Windows, for Linux, for AIX, whatever. But also maybe not directly on that page, but I could run it on Kubernetes. And just like how, as a Splunk admin, I would need to know, well, if I'm going to install this on Linux, I got to know some Unix. I got to know how to navigate and do commands and so forth. What I'm hearing from you, Sirish, is it's kind of equivalent. If you're installing this on Kubernetes, you have to know how to be an administrator, just enough to install and run and that type of thing.
So Bert, you made
exactly the way that I was to say that's exactly the way that we're treating it as well. Is it's just another. In fact, Kubernetes has kind of evolved as it's the cloud operating system. It's a distributed operating system, a clustered operating system, and that's exactly how we think of it. As just another platform for us to deploy on.
So Birch mentioned the download page. I'm thinking, because I know a little bit about how these mechanics work. That's not how this is distributed, is it?
No, this is all done. Well, there's a couple of different methods. The container, when you actually bring up a cluster, container is actually obviously grabbed from Docker, right? So the Splunk Enterprise container that
might
ends
not be
up
obvious to everyone. So let's unpack that just a tiny bit. What is being downloaded from Docker and why?
Sure, it's just the container that contains the Splunk D bits, and that could be one if we're doing a single Splunk container or a single Splunk pod, or it could be 50 if we're creating a search head cluster and an indexer cluster. We could download many at the same time, and then sort of the stitching that keeps it all together, as Sirish alluded to, is there's some YAML files that define exactly what the clusters look like, how big they are, what they're talking to, what services they reference. Like the search head cluster service references the indexer cluster service, and that's how we do distributed search. And for the setup, to your point, it really is just it's a kubectl, kubectl command, and it's kubectl apply, and then we basically just pass it a Splunk YAML file that we've created, which sets up the service for Splunk. Goes out and grabs all of the Docker containers and basically readies your environment to start running Splunk under.
So speaking of this asymmetric relationship Birch has with Patrick. Patrick, do you remember, this would have been 2013, when I was lobbying to get us to set up an RPM repository so people could download Splunk that way?
Yes.
You do.
I also had an effort doing that, not knowing about your prior effort. I feel like for every 50 people that worked at Splunk, maybe there was one person in each wave that was like, hey, can we get an RPM in the repo so it's easier to install?
Yeah. So
I also thought that was a good idea.
Got there, but the place we got to was different than when we started, but we actually got there as far as distributing software in a repository that is used by a community of, consumers of software.
Yeah, that's exactly how it works too. I mean, you still have to apply a license at some point during this process, right? You still have to put your Splunk license in it, but everything else, the Docker Splunk pulls from the currently available, the latest version of Splunk, and as of yesterday, or actually even Monday night, 8.10. So everything is kind of getting updated in that patch. So this is I would call it the cooler next generation version of the RPM. And more importantly, not only just for single instance, like I just want to pull a single forward or a single version of Splunk Enterprise down. This is using container orchestration, so we can build distributed Splunk deployments and really of any size. We've run this actually at customer beta sites. I think we ran I don't know how many, there were literally hundreds of different instances of containers of Splunk indexers and search heads running an environment. And that was even with our alpha version of the software. So it works very well because we actually use a lot of the same components internally to build and test Splunk itself. In fact, Splunk Ansible and the Docker Splunk projects were outcroppings of internal projects where we were building clusters to do tests against as part of our definition of merge, our DOM process, before we release Splunk Enterprise. So a lot of this
is really first class now.
Yeah. It actually works.
So I got. Oh, go ahead, Sirish.
So I was just about to add to what Patrick was saying from a scalability perspective. Just to give you some perspective, right? That one single YAML file, which is dedicated for, say, all the indexes in an indexer cluster. Just to simplify, if I wanted, say, 100 indexers in a cluster, all I have to do is to toggle a certain field in the YAML file, which is called as a replicas, and I say, hey, I want 100 indexes, and then apply it with one command. And the next thing, the operator does its magic along with the Kubernetes infrastructure to create 100 indexes within a cluster. So it's as simple as that from an admin's perspective.
And then X number of minutes later, those are ready to go, and they are ingesting data and serving queries.
Maybe
Exactly.
not even minutes, maybe seconds.
Wow.
Yeah, I have a little cluster that I run in EKS, and I bring up a 3-node indexer cluster, 3-node search head cluster in under 30 seconds.
Wow.
So
is there anything that you would not use this for? The reason I asked this question is that today, if you go to our support page and you look at what we support Docker, Splunk in a single standalone instance only. Right now, I know you're beta, so we're not GA yet, but for this operator, are there going to be constraints that we need to understand?
Yeah, I mean, I think it's just also a matter of people's comfort level with Kubernetes. Like we said just a few minutes ago, is there's some basic things that you have to learn about either operating Kubernetes on premise, if you're running it, say, under OpenShift or Esmeralda or one of the other sort of non-public cloud service providers, or if you're running it in EKS, GKE. I think it's really just about comfort level with with navigating some of the new services and whatnot. But yeah, as you alluded to, we are in beta, so the running Splunk containerized in distributed environment is actually not even supported yet, and that's what our goal is to do with this project, is to lay the foundation such that customers can use this in a fully supported manner.
So I now have 3 questions. The
All right.
first one is fun. Is YAML the one where it's yet another markup language?
Yes.
Okay. It's like PHP being recursive. Like I just get a kick out of those. Okay. So now for some tech questions. I'm trying to picture the data flow. So I as Sirish was saying, I now have 100 nodes. And I assume because it's so trivial, like I can scale up and scale down, and then that implies eventually I could even have some auto scaling type of functionality. But let's talk about the data flow, because typically we don't, Splunk software typically doesn't have like DNS or anything. Like we want the forwarders to maybe do indexer discovery or have in the configuration file a listing of all the different indexers that they can send data outputs.conf to. How does that work in this more dynamic Kubernetes world where I might now have 100 and in 30 seconds later I could have 1,000, and my typical phone home for the deployment server is going to be default like 30 seconds. So there must be some kind of change there, right? I guess
you want to take that one?
How do the forwarders know where to send the data to?
Sure. In fact, that is one of the things that we have, as prioritized as part of our backlog, wherein we want to focus on, now that we have built the operator, to be able to set up the indexer clusters, the multi-site indexer clusters, and even the automated monitoring console. But that's something which might please you, because it's not just a monitoring console; it's something which is already configured out of the box. But on top of all of that, what we also want to do is to work with different customers to try and understand how do they actually want, where do their forwarders sit, within the cluster, outside the cluster, and so on. Get a sense of the real world use cases, and then set up things. Maybe it's just an infrastructural thing within Kubernetes, set up ingress and other services which can accept the data from the forwarders and do the balancing. Or we can probably have maybe indexer discovery kind of a service built in within one of the containers, which can help us do the routing. Or it could be any other strategies that we want to take. So in other words, it's still
so we have
a
a couple options. Yeah.
That's right. Yeah.
Oh, very cool. So there's a couple options, and we still are figuring out the path there based on what's going to be best for the customers. So now the data, let's say the data is received through a solution to be named later, from our menu of options here. Data gets indexed. Now, again, putting on my Haggard costume, hey, I save things locally to disk. And when I've got the number of indexers going, to 100 or 1,000 or down to 3 in seconds, doesn't that mean all that data that was stored is just gone now because it's no longer on those nodes?
One of the requirements of a Splunk operator is the need for having a smart store. So when the operator actually sets up the indexer cluster, out of the box, we don't mandate it, but for a real use case like what you just described, Butch, we would also want the customers to set up some sort of a smart store, right? And using the smart store, Splunk is going to use its S2 functionality and upload the data that it is ingesting onto the smart store itself. That should solve the problem that you just described. Yeah.
Okay, so Smart Store, something that we came out with, I don't know, a year or two, or I've lost track ago. It's going to allow, the indexers are now just workhorses for both writing the received data into cloud storage, as well as serving the results of the search requests from that data in cloud storage. And then each of those indexer nodes is not persisting the data locally, it's actually caching it. So it's both acting to write to the disk and then keeping a cache. And so now you're able to fluctuate the number of indexers based on your workload needs, not necessarily based on like retention or whatever. Did I sufficiently use my hands for that explanation?
Yeah, absolutely. Okay. Very well described. Very well described.
Okay.
Yeah.
We still rely upon having a small degree of local storage for hot buckets. We're running Smart Store essentially. So it's not completely ephemeral. We do, but the good news about that is, even if we are streaming things, we're writing the local hot buckets. Under the case of Kubernetes, this once again comes back to having the Kubernetes backplane gives us a lot of extra things that we don't get sort of out of the box, just the Splunk tier with the application layer availability. We're writing to what we call a persistent volume claim on the hot buckets. And if for some reason Kubernetes detects that there's an unhealthy state in one of the indexers, it will offline that and then actually disconnect the persistent volume claim, basically the storage volume from the indexer, go grab new resources, recreate the container using the Docker container, and then reattach to that persistent volume claim.
Wow.
And then the cluster will start its rebalance via the marriage of indexer clustering plus the Kubernetes state and sort of monitoring. So it will offline itself, rebuild and rebalance. We are also looking at methods by which we, with the introduction of multi-site, and that's another cool feature. We're trying to hit on all the cool stuff that we did for the beta. Supporting multi-site was an early requirement from one of our large alpha customers. So we made that possible with actually splitting the cluster master CRD out from the cluster, the indexer cluster itself. And now we actually do support multi-site indexer clusters, but we're thinking about potentially, finding ways that if we could use multi-site indexer clustering instead of not requiring those persistent volume claims, that we might actually be able to get to a place where the indexer is either close to or almost entirely ephemeral, and we don't even need those persistent volume claims on the indexing tier.
And I guess if the customer had already solved storage with their Kubernetes environment, I mean, you can have storage drivers for those persistent volumes to point to a SAN if you wanted to. You could always do that too, right? There'd be nothing stopping you from that. Okay, awesome. We're gonna have to close here in a few minutes, but I wanted to make sure that people had a takeaway for you in the beta. So
let's give them homework.
So where should we send people, Patrick, and what are your kind of goals here the next that you can share?
Yeah, sure. If you go to GitHub and just look for the Splunk operator, you should be able to find it. In fact, I think I sent a link to, there it is. Thank you very much.
Dropped it in chat.
There is, that is our main landing page. This is an open source project. So in fact, even within the course of the current alpha that we just came through, we actually took pull requests from customers that needed certain features. So thank you to the community, thank you to our customers that are helping us shepherd this along as well. Yeah, that's where you can start. And then there's also a more formal sign up page that you can find off of Splunk.com. But really, just to get started, it's just the easiest to go to the GitHub page and then come off of this.
So yeah, I think open beta, fire away.
It's an open beta, and then we'll actually be also working with a couple of, we call them white glove customers that will be setting this up in larger environments. But the time frame for us to move this out, I see that there's a question in the chat room about the ETA. We're working on it. We're actively working on it. I can't reveal an exact time, but let's just say that we are targeting this to happen within the next calendar year. So within calendar year 21.
Awesome.
Cool.
So, Sirish, what are some I guess kind of the things that you've learned while building this and with your team?
It's been an amazing journey. I mean, last few months, the team that started working on the operator started actually from scratch. We didn't worked on, although these are all Splunk experts, we hadn't worked in Kubernetes as such, but the way we've actually ramped up the technology itself is so interesting. So much that we've got a strong engineering team which has become passionate about the whole technology. As part of that, I think what we have also learned is thanks to Patrick to make this happen, we've also been talking to a lot of customers, trying to understand the real world use cases and so on. This is an emerging technology. We can see that even the customers are trying to evaluate how they want to use Kubernetes in their private cloud and how they want to bring in Splunk and so on. So a lot of exciting technology that we've been adapting Splunk in that particular environment. And yeah, just looking forward to the future use cases that customers have. We'll continue to work closely with the customers to understand the use cases and prioritize our backlog.
Very cool. And are there any talks that you want to that either happened yesterday and people should replay, or happening today that you want to point them to?
There was an interesting talk. I think you look for Ryan Faircloth. Did a talk with it was Intel, some other folks about modernizing technology and modernizing infrastructure. And the project that he's referring to was based upon the alpha version of the Splunk operator, which is interesting.
Cool.
Well, thanks a lot for your time, Patrick and Sirish. We really appreciate you sharing what you've been creating over the last few months, many months. I know it takes a long time to bring these things to market, so thanks for your hard work.
Sure.
Thanks, sir.
So
thanks
everyone from
having
here should head over to the main conf site and get ready for the first ever customer success keynote.
And watch the stream. We'll be on a few more times today. Next up is several hours. We'll be talking security with some of our friends, Jim Apgar and Kyle Champlin.
Nice.
All right, that's it for us. Thanks, everybody.
Happy splunking.
Thank you. Bye bye.
Bye bye.